My name is Abrar Ahmed. In this video, we will learn about the DOL starter, that is a direct online starter. Before moving to the direct online starter, let us discuss some of the important motor starters. In order to start an induction motor, specifically a three-phase induction motor, certain starter circuits are used. These may include direct online starter, star delta starter, variable frequency drive VFD, soft starter, etc. There are numerous other starter methods and starter circuits for induction motor as well. Quickly moving towards the DOL circuit and its components. A DOL direct online starter is the simplest starter in which we can start a three-phase induction motor. The main and essential components which are minimum required to make a DOL are a magnetic contactor, thermal overload relay, fuse or miniature circuit breaker MCB, start-stop button or on-off switches to on and off the motor remotely. So now I will show you these components one by one and we will have a little bit discussion about it. This is a three-phase magnetic contactor. These 3 points, point number 1, 3, 5 are the points where the three-phase incoming supply is attached, and these are the 3 points, point number 2, 4, 6 are the points from which we get the output. These are the power contacts of the magnetic contactor. This magnetic contactor has a control voltage of 220 volts, which means that when 220 volts will flow through its coil, the magnetic contactor will be picked up and these contacts will become closed. There are two auxiliary contacts, namely normally open contacts 13, 14, normally closed contacts 21, 22. When the contactor will be picked up, these contacts will change their positions. Next is a thermal overload relay. This is another important essential component of DOL. There are two contacts, 95, 96, normally closed contacts, 97, 98, normally open contacts, which will change their states when this relay will be picked up. This is a reset button which will be pressed when this relay will be tripped on overload. So in order to reset, this button will be pressed. This is a knob which is used to set this relay depending upon our own requirements. Another important component is a fuse or miniature circuit breaker. Either of the one thing, either a fuse or an MCB can be used. This is an MCB and it is used to protect our control circuit. Lastly, these are the start and stop buttons which are used to control the motor. Stop button is normally closed and start button is normally open. Now I will show you the diagram of these starters and three-phase induction motor connections actually. These are the wiring and connection diagrams. This is basically a power diagram. These are the three phases. This is a fuse load assembly. We can also use MCBs in respect of these fuses. These fuses are connected in series with the incoming supply. After that, there is a magnetic contactor which is again connected in series. These are shown the power contacts which I have just showed you. Then there is a thermal overload relay which is connected just at the output of the magnetic contactor, and finally this thermal overload relay is then attached to a 3-phase induction motor. Now this is a control circuit diagram. In this diagram we have used the control supply voltage of 220 volts AC. This is the fuse, and we can use MCB here as well. This is for the protection of our control circuit actually. This is the stop button or off push button. This is the start button or on push button. These are the contacts of thermal overload relay, which are normally closed contacts of thermal overload relay 95-96. This shows the relay coil and the two terminals A1 and A2. This is the coil of the contactor, main contactor. This 13 and 14, this is a normally open contact of the magnetic contactor C1. Now let us discuss the current flow through this circuit. When this on push button it will be pressed, the current will flow from this side and it will flow inside the coil of the contactor. The auxiliary contacts, which are normally open contacts 13-14, it will be closed, and then the current will flow in this direction to energize this coil. In next step we will implement this control diagram practically. This is the magnetic contactor, and as you can see that this is the coil of the contactor and the terminals are A1 and A2. So this is the A2 terminal, this is the A1 terminal of the coil. So A1 is connected to 96 of our thermal overload relay. 95 and 96 is normally closed contact, and one of the terminal of coil, it is connected to 96 terminal of the coil. Then the contact number or the point number 95 of this thermal overload relay, it is connected to contact number 14, which is a normally open contact of this magnetic contactor. Also it is connected to on push button, which is over here. So this point number 95, it will be connected to point number 14 on a magnetic contactor, and on push button over here. The contact number 13, it will be connected then to the off push button and also the other terminal of the on push button, or in other words, one per terminal of this off and on push button, they will be shorted, and point number 13 of this magnetic contactor, it will be attached to the common point of these two. Finally, the other terminal of the off push button, this stop button, it will be attached to the MCB, which is miniature circuit breaker, which we are using here. We can also use fuse in respect of this, and then this will be a supply coming out from it, and it will be attached to 220 volts AC mains. And one thing remaining, this is the terminal A2 of this magnetic contactor. It will be attached to neutral. So we will be having our wires at which we have to supply the 220 volts AC at point number A2 here, and the miniature circuit breaker MCB here. Now this is the circuit which is made after the necessary connections and wiring. Note that I have done nothing except implementing this circuit on these components. This assembly is basically called a DOL starter. Now I would like to tell you that where the motor is connected on this assembly. This is the 3-phase input supply, and these are the terminals on which the motor is connected. So now let us test it. This is the start button, and as you know, when I will push the start or on button, the magnetic contactor will start running. In turn, it means that our motor will be started. So pushing this, you see the magnetic contactor is picked up now, and it means that these contacts are shorted. In turn, the motor will start to run. If we want to stop our motor, we will simply press the stop button, and as you see, the coil is released and the supply is disconnected, which means that our motor will be stopped now. Now if we check this thermal overload relay, you see I have pressed this test button. The magnetic contactor is released, which ultimately means that the motor is stopped now. I told you that this blue button is basically a reset button, and when the relay will be picked up, we have to press it to reset to its initial conditions. If we do not press it and just press the start button now, the magnetic contactor will not be picked up, and it means that the motor will not be on. So see, by pressing the start button, the motor is not running and magnetic contactor is not picking up. The main reason is that we have not reset the relay. If I press this reset button, and now I have pressed this reset button, if I press this start button, so you see magnetic contactor has picked up. So now if I stop it, so you see it is stopped again. So that was all from my side. It was a demonstration of the DOL starter circuit. So it's quite interesting, and let me know if there is any confusion still. Thank you for watching.